All right, this is PSAT, October 13th, 2021. If you've already taken this, hopefully you go on College Board, you look at the questions you missed, and you can fast forward through the video to get some help on those. Some of them you may also want to take a look at just for speed, like maybe you got it right, but it took you way too long, so you can kind of watch some of my shortcuts. If you haven't taken this test before, I'll send a link in the description to where you can do a gradable test. It's just a PDF, and you fill in the answers, and it'll auto-grade it for you and tell you which ones you need to work on. So here we go. Let's get after number one. This is just pretty much straight up algebra. We have variables on both sides. So let's solve this. So 12n plus 9 equals 6n minus 9. I want to get all my n's to one side. So I like to subtract the smaller amount of n's. So I'm going to do that to both sides. I get 6n plus 9 equals negative 9. Subtract the 9 from both sides. We get 6n equals negative 18. Divide by 6, divide by 6. Looks like n equals negative 3. The correct answer there is A. All right, scrolling on down to number 2. This looks like some sort of an exponential decay problem. And it's a graph, which can be challenging for people, but this one actually looks pretty easy. Because the big thing to know is that with powers, when x is your exponent, so like let's say you have 2 to the x power, if x equals 0, 2 to the 0 power is just 1. And there's a rule that says, I don't care what you are, blah, 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 anything to the 0 power is going to be 1. So when I go through and I look at these, when x equals 0, what does y equal? Well, right there is the point when x equals 0, and it looks like y equals 6. So looking through these, the only choice that could be that would be choice B, because when x is 0, remember order of operations, you're actually just going to do this piece first. You're going to do 1/3 of the 0 is 1, and then 1 times 6 gives you a y value of 6. So the correct answer there is B. So just know that little trick of anything to the x power is 1. Moving up here to number 3, we have some sort of a word problem. Another exponential. Says the number of subscribers to a newsletter can be modeled by this function. F of x is the number of subscribers on the xth day after the newsletter. So when you plug x in, that's how many days after the newsletter first came out. So which of the following is the best interpretation of f of 10 equals 200? So f of 10 equals 200. So remember, x represents the number of days after publishing. Okay? So what this means is 10 days after this newsletter was published, well, what was the 200? F of x is the estimated number of subscribers. So after 10 days of publishing, we expect to have 200 subs. So where does that say? Looks like that's part A. Let's just double check. B says 10th day, 200 more. No, that's not the case. On the 200th day, no, those are just mixing up variables. So the correct answer there is A. All right, number 4. This is kind of a classic. Always this problem is on every single SAT. I can just look at it and I know where they're going to get people. You're subtracting an expression there, which means you're going to have to distribute that negative through the parentheses. So we're just going to do the distributive property. And that's going to be negative 15, x times x is x squared. Negative 5 times a positive 2, that's negative 10x. Now over here is where you got to be careful. I got a minus 3x, so that's minus 3x squared. Then I'm going to have a minus 12x. And looking through, doesn't match up yet, so let me gather up some like terms. So I have some x squareds, and I have some more x squareds, so let's slap those together. Negative 18x squared. I got negative 10, negative 12, that's a negative 22x. Looking over here to the left, it looks like every single answer, they're factoring something, they're pulling something out. If I were going to factor this, I would pull a negative 2x out. But when I look over here, that's not, part D isn't going to work out the way, like it doesn't come back to equal what the problem was. But when I look at this answer and I compare it with C, I would get a negative 18x squared and I would get a negative 22. So the correct answer here is C. This is just one of the many things they do. Sometimes you solve the problem, but they repackage the answer. So you have to be really good at knowing how to find equivalent expressions. So it's kind of another little dirty trick that they do. All right, let's check out number 5. This is a linear graph. I see the word perpendicular in up here, so kind of some old school geometry. So line N is shown in the XY plane. So this line right here, this is line N. Line K, which is not shown, is perpendicular to N. All right, so we need to find the slope. So here's how we're going to do. Let's find the slope of line N. Well, I got to find a lattice point. I got to find where does it cross perfectly and cut through a corner. And I think I see 2 spots right there. So that slope is going to be a rise of 5 and a run of 1. So my slope is actually going to be 5. Or if I want to get technical, it's 5 over 1. All right? And I know it's positive because it's increasing left to right. Well, if I'm going to be perpendicular, the slope of K, so a couple things. When you want to be perpendicular, you have to do 2 things. So to be perpendicular, 2 things. Number 1, you have to have the opposite sign. So I know that K is going to have to be negative. Number 2 is it's going to be the reciprocal, aka the flip. So it's an opposite flip. So flipping 5 and 1 gives me 1/5. So the slope of line K is negative 1/5. Now, if you chose D, which a lot of kids do, you just basically looked at the picture and found the slope of that line. And you kind of didn't read it that you had to be perpendicular. So be careful. Pretty common question on every test. Linear graph. All right, number 6, this zigzag line. This is function graph. So biggest thing I want you to understand is that f of x is really the same thing as y. Just always treat it as y. So when they say, how many solutions does f of x equals 0 have? They're like, hey, how many times does y equal 0 on this graph? And I see it happen 1, 2, 3 times. So the correct answer here is C. So that's just a function graph. Slipping on down to number 7. What do we got going here? A geologist places a beacon on the leading edge of a glacier to measure its speed. A stationary receiver is placed 200 feet away. So just kind of going up to my picture here. It looks like this distance is 200 feet. The beacon is observed to move at a constant rate, so it's linear. After 30 days, it's 185 feet away. All right, so if I got to make a little table here, and I'm just kind of like, hey, we got time and we got feet away. All right, well, at time 0, we're 200 feet away. And it says after 30 days, so I'm going to put days here for my time. So after 30 days, we're at $1.85. And it's going to be constant. So this is a linear table. So assuming the beacon continues to move at the same rate, how far will it be after 90 days? So we can just jump by 30s. You can see what happened here. It was basically, we're dropping by 15 feet every time. So 60 would drop another 15 feet. 90 would drop another 15 feet. And so how far will the beacon be? How far from the receiver? So it'll still be 155 feet. So the correct answer there is C. All right, moving right along over here to number 8. Scroll up a little bit. And this one, to try to fit the whole picture out here, I'm going to have to shrink the view just a little bit. Zoom out. There we go. Lots of ways to kind of do this problem. I'm going to show you the fastest way because time is of the essence on this test. First thing is, let's find the equations of these two lines. So looking at this line right here, I'll just call this the blue line. It's got a y-intercept of positive 2, and it's got a slope. It looks like it's going up 1, right 1. So it has a slope of 1. So that line is y equals x plus 2. Now, I do see that it's shaded above the line. And when you're shaded above a line, that means that you are going to be greater than. So y is greater than, and then it's equal to, because this is a solid line. So I know that's one of the two equations. So let's peek at our answers. No, no, and all I got left is the bottom two. And actually I'm done, because notice this is less than, this is greater than. Correct answer is D. I could have found the other line too. Maybe just really quick, I'll show you that. This one crosses at a negative 2. It has a slope that's going up 3, right 1. And it's y. Again, we're shaded above. So that would be the other one. And that fits for D. So moral of the story is, when it's y is less than, you're going to shade, if I can spell shade, you're going to shade below. And if it's y is greater than, you're going to shade above. Now, a lot of people talk about picking test points and plugging it in. That's all fine and dandy, it works, but it takes too long. So screw that. All right, number 9. Let's zoom back in a little bit. Which linear equation has no solution? All right, so no solution, the only time that can happen is when basically all of your x's disappear and you have a false statement. So for instance, here's a classic. This problem is unsolvable because any number I put in for x, the right-hand side is going to be 1 bigger. And notice when I try to solve it, when I subtract x from both sides, I get 0 equals 1, which is a false statement. So that tells me there's no solution. That's a symbol for no solution. So when I look at this one, I clean this up. This first one says 6x equals 3x. Well, that can be solved. When x equals 0, that equation is true. The next one, 6x plus 1 equals 4x, that's fine. The next one, I have 6x's here, 5x's here, that's fine. It's this bottom one where there's a problem. 6x plus 3 equals 6x. When I subtract 6x from both sides, I get that 3 equals 0. So I know the correct answer here is D. So moral of the story is, you have to have the same amount of x's on both sides, all right? And different numbers, different constants. Otherwise, it would be infinite solutions. For instance, if you have an equation like this, and maybe I just go 2 times 3x plus 1. Well, that equation, you might try to solve it, but when you distribute, you realize that it's the same thing on both sides. And if that's the situation, it's going to be infinite solutions. So sometimes every test, they kind of alternate back and forth between infinite or no solution. I call those freak cases. Just understand how the freak cases work. All right, number 10, we have a quadratic. It looks like it's in standard form because we have ax squared bx plus c. So none of those are 0. If we have exactly one solution, all right, one solution, what must be true? Well, how you can determine the number of solutions to a quadratic. So number of solutions to a quadratic. Remember, a quadratic has its largest term as x squared. If you remember the quadratic formula, and you have to kind of memorize this on the test, it's negative b plus or minus square root of b squared subtract 4ac all over 2a. You probably remember that if you had algebra or algebra 2. But the big idea here, the big thing to take away, is this piece right here is called the discriminant. All right? So discriminant. Not that important to know how to spell it, but know what it is. Basically, if that discriminant is greater than 0, meaning it's positive number, you're going to get 2 real solutions. All right? If that discriminant is equal to 0, you get 1 solution. And then if b squared minus 4ac is less than 0, then you get no real solutions. And that's where you get the I and the imaginary numbers. All right, well, we wanted to have exactly one solution. So we need b squared minus 4ac to equal 0. Well, I don't see that over there, but I do notice if I manipulate this a little bit and I say, well, why don't I add 4ac to the other side, just plus 4ac, I will get choice C. So it's kind of a sneaky way because you had to repackage it, you had to manipulate the expression. But the big idea here is know how to find the number of solutions using the discriminant. All right, number 11. Let's see what we got here. So a farmer can grow 30 tons of pumpkins. Up. See if I can kind of get it all in without zooming too far out. All right, a farmer can grow 30 tons of pumpkins per acre in soil type 1 and 20 in soil type 2. Plans to grow 360 tons total. So we have an equation. So let me just kind of jot this down really quick. 30x plus 20y equals 360. And x and y are the number of, so which graph represents it? All right, so easiest way, this is called standard form. You know, most of you guys are probably more familiar with slope intercept form, which is y equals mx plus b. But standard form is actually kind of nice because it's super easy sometimes to graph by the intercepts. So I just make this little kind of cheat table here, and I let x be 0 and let y be 0. So to find the y-intercept when I let x equals 0, you know, basically I'm just going to cover up this part. Just kind of imagine your hand covering that up. And solve 20y equals 360. So that means y equals 18. All right. Well, then plug 0 in for y. You know, so now you're going to basically put 0 in for y. So you're going to cover up the 20y part. And just solve 30 times x equals 360, which is going to be x equals 12. And now I just have to graph that. I just have to find those two dots. So 0, 18. This one looks good. This one, nope. This one, nope. Oh, this one, nope. All right, correct answer is A. And I see the 12 down here, 12, 0. Now, if you like working harder and you like working longer, or you forget to do the intercepts, you always could put this in slope intercept form. You know, subtract the 30x from both sides, and then basically divide everybody by 20, and you'll get y equals negative 3/2 x. What's that? Plus 12. And you would, again, hold on a second, because now, no, plus 18. What am I doing? Plus 18. And you would again see the y-intercept is 18. He was the only one that had that y-intercept. And then you could also look at the slope if you wanted to, but that takes too long. Just use the intercepts, you'll be in better shape. All right, next to number 12 and 13. What is the maximum value of this function? So this you learn in algebra and probably algebra 2 again. This is called vertex form. So vertex form, and it's a quadratic because you see that squared there. So in vertex form, basically every piece of vertex form changes or transforms the equation. You know, in general, vertex form looks like this. It's y equals a times x minus h squared plus k. And the big idea to take away from this is this controls your left and right. So this moves something left and right. This controls up and down. This number in front can stretch something, or it could reflect it. So if it's a positive number, it's going to look like this. If it's a negative number, it's going to look like that. All right. And this one, since there's a negative in front, we are going to have a maximum value. And our maximum value is going to be right there at the peak, at the vertex. Okay. So basically what we want to find is we want to find the vertex, the x comma y, and that max height is going to be this y value. So ultimately, that's what we're trying to do. All right, so let's peek at this problem here, and I'll kind of teach you how to do this. So to find the vertex, it's really easy. Basically, inside the parentheses, it's always the opposite of that number. So right now, you see plus 100. So the vertex is actually at negative 100, which really doesn't matter for this problem. But this part over here is the y value, and that's just the same. All right, so the key thing to remember is the x is the opposite, the y is the same. So the vertex is at negative 100, negative 50. This is the highest point on the grid. We could graph it, and that would shake out. So the correct answer here is B. You could go back and watch some of my videos on vertex form if you wanted some deeper knowledge on that. All right, number 13, looks like we have to solve a system of equations. This one looks a little bit nasty, just because we have this x squared minus y squared. You know, normally they're both linear. They're both just x's and y's and numbers, and you can use substitution or elimination. This one, though, I kind of see a bit of a trick. This is the difference of squares, this x squared minus y squared. So if you remember from algebra, the difference of squares, I can factor that into x plus y times x minus y. That'll give me x squared. The middle terms cancel out, minus y squared. And I know that equals 100. And then they basically tell me what x plus y equals. They're like, hey, x plus y is 5. I'm like, oh, thank you. X plus y is 5. Well, now it's a pretty simple equation because it's pretty much just saying, hey, man, 5 times what equals 100. So I don't really know what x and y individually are, but I know that x minus y has the total up to be 20 because 5 times 20 is 100. Correct answer is C. So that one's a little bit tricky. All right. Number 14. Now this is just a good old-fashioned systems of equations. I like these. Pretty straightforward. I got to find what the value of x is. So if I want to find the value of x, my move is I'm going to eliminate y. So how I eliminate y is I'm looking at coefficients, the numbers in front of the y's, and I need to get them to be opposites. So notice how right here I have a minus 2. I want to get a plus 2 on the top. So I'm allowed to multiply that whole row by 2. So I'm going to do 2x plus 2y equals 24. I have to multiply everybody by 2. The bottom, I have x minus 2y equals 9. So now I'm just going to come in here and I'm going to add these two equations together. I'm going to combine my rows. And I get 3x, you gone. This is going to be 33. Divide both sides by 3. And we get x equals 11. So correct answer here is 11. Sometimes you have to go back and plug 11 in and get the other number, which I can just kind of see in this case that when I stick 11 in right here, 11 plus what equals 12? Y equals 1, but that wasn't really part of the question. But be sure to know how to do that. Next question, number 15. What do we got here? Looks like something to do with geometry. P of w equals 8w plus 4. The function p gives the perimeter in inches of a rectangle with a width of w. So all this really says is, hey, you stick a w in there and we'll tell you what the perimeter is. So what else do we need to know? It says of a rectangle that has a width of w and a length of 3w plus 2. All right, so let's check this out. I'm going to draw this. When in doubt, draw a picture. So if the length is 3w's plus 2 and the width is just w, all right, for every inch that the width increases, how many inches will the perimeter increase? All right, I guess I didn't even really need this picture because if P of w, the rule is you just do 8w plus 4. Well, let's let w equal 1 inch. If W equals 1 inch, and I drop a 1 right here, 8 times 1 plus 4, well, that's 12. All right. Well, if I increase it by another inch, if I drop a 2 in there, 8 times 2 is 16 plus 4. Perimeter is going to be 20. You know, if I drop a 3 in there, perimeter is going to be 28. So it looks like, how many inches will the perimeter increase? It looks like we are increasing by 8 every single time. So the correct answer here is going to be 8. All right. Number 16. Gotta scroll down or up. Gotta go up. All right. We got a McNasty one looking here. Again, quadratics. So you can see this no calculator is pretty heavy on quadratics, so be good at it. We have a quadratic we want to solve, and I can see right away we're getting some square roots and stuff in here. One's positive, one's negative. So I'm thinking quadratic formula. Usually I try to factor this thing, you know, so normally I'd come over here and I'd be like, all right, let's try to factor this joker. And I'm trying to find two numbers that times together to make 2. Well, there's only one combination. But add together to make -4 ain't going to happen. So this is not factorable. So I have to use the quadratic formula. So this is a second time we need to have that memorized, that -b plus or minus b squared minus 4ac all over 2a. They don't give it to you. You got to know it. Well, let's look at it. So a is the number in front of x squared. So a is 1. B is the number in front of x, -4. C is the constant, 2. So let's slap this all into the quadratic formula, see what shakes out. So -b, so -4, that's a +4, plus or minus the square root of b squared. Now, don't punch this in your calculator. If I had $1 every time I get a kid punch that into their calculator, that says -16. Well, that's not what we're doing. We're doing -4 squared, which should be +16. Well, you don't have a calculator on this one anyway, so I guess I don't need to preach. Just do it in your head. -4 times itself, 16. Take away 4 times a times c all over 2 times a, 2 times 1. All right, we got to clean this up. So we have 4 plus or minus the square root of, well, that's 16, take away 8, which is just 8 all over 2. Now you got to kind of be careful. Different teachers teach us different ways. From what I found is most kids have the easiest time simplifying a radical by doing what I'm about to show you. So a little side lesson here. How to simplify radical 8. What you do is you do a factor tree. You probably remember this from pre-algebra. So break 8 down any way you want. I don't care. 2 times 4. Circle your prime number. 2 times 2. I just broke it down as low as it can go. Well, what you do now is you find every pair. So I have a pair of 2s. You count that once. If you had more pairs, you keep counting them once. And then your loner, you know, this dude's a loner. He doesn't have a pair. The loners go under the radical. So this is actually 2 radical 2. So I'm going to replace this thing. Instead of radical 8, I'm going to call that 2 radical 2. And then we got to divide it by 2. Now, key thing to know here is when you're dividing that big number on top, there's 2 pieces divided by 2. So break it up. 4 over 2 plus or minus 2 radical 2 over 2. So this condenses down to just 2. These 2 cancel out. So if this was just like a straight up normal question on a test in your class, the answer would be 2 plus or minus radical 2. But they do this weird stuff. They say, hey, you know, ultimate question is, what is the value of t? Well, t is just whatever number is sitting inside of that radical. So our number that's sitting inside of the radical is 2. So the correct answer to this question is 2. I've also seen tests where they might ask you what r plus t is. You know, so you might have to go r plus t to get the answer, or r take away t. They do all kinds of weird stuff like that. All right, number 17. This one, what do we got? We got a box. Gift wrapping company charges customers based on the surface area. 30 cents per square foot of surface area. What will the company charge in dollars? Don't write the dollars. All right. So this is just straight up old school geometry. So I'm going to kind of just finish this little box, make it look pretty. All right. So, you know, there's formulas for surface area if you want to remember those. And I'm not really big into memorizing a bunch of extra formulas. What I know is this thing has 6 sides to it. All right. And I have some sides that match. So first thing is I have a top and I have a bottom that I want to find the area for. And if I look at the area of the bottom and the top, it's just 2 by 2. So 2 by 2 is 4, but I have a top and a bottom. So it looks like I have 8 for the top and the bottom. All right. Well, now let's knock out, let's say the right and the left. All right, the right and the left over here. Well, those dimensions are 2 by 1. So the right and the left is just 2 times 1, which is 2. And I have a right and I have a left. So it looks like we have 4 square foot for there. Now, the only thing I haven't done so far is I haven't done the front and the back. All right, those should match. And again, those are also 2 by 1. So my front and my back are also 2 for the front, 2 for the back, another 4. So grand total, all 6 sides, 8, 4, 4, we have 16 square feet. All right. So now what I can come in and I can say, well, they're charging me 30 cents per square foot. So it's basically 16 times 30 cents. And what's that? 48. So $4.80. But you don't put the dollar sign. So I probably shouldn't put the dollar sign. You're just going to bubble 4.80. Boom. All right. What else we got? All right. Looks like that wraps up the no calculator section. So you could now move on to the next video and try the calculator section. See you.